but my name is Erin Braich. Prefer to go by Bear. It's been a nickname that was given to me. I'm in the Department of Urban and Regional Planning, and I'm a part of the Sea Grant project integrating climate science for local knowledge in West Kauai. And I've loved being a part of this project throughout my education in the department. We've been preached and it's been forced to us that we've been taught the technical skills of how we go into a community and we're given, we know all of these things and this is how it's supposed to be fixed and so on and so forth. But with this project, it's been amazing because I just sit and I listen to the community, and I'm really good at it because I was given huge ears as a kid and I still haven't grown into them. So I have just loved being a part of this.
Can you speak into the mic?
Oh, yeah. It's still.
I'm waiting for Tyler to come help me.
Okay, well, I'll still go. I'll just keep going. But so with this, in December of 2017, the state of Hawaii released a statewide sea level rise vulnerability report. And that showed a statewide vulnerability assessment for sea level rise for all coastal areas in the state. And then with that, earlier this year in March, the County of Kauai updated their general plan and used a coastal hazard assessment on sea level rise to also assess what areas are vulnerable. And they came to the conclusion that 3.0 feet should be included in all building plans and should be planned for today. So with that, a Sea Grant project was birthed, and it was titled Integrating Climate Science for Local Knowledge.
That's the problem. Got it? Wherever this goes. There you go.
All right. Oh, we were just right here. All right. So with that, a Sea Grant project was came out of that, integrating climate science with local knowledge for a community vulnerability assessment in West Kauai. And West Kauai was selected for the County of Kauai because they were the last time they have had their community plan updated was in 1974. And once a county's general plan is updated, the community plans then need to be updated as well, so their policies and goals are coherent and they match up as well. So this is a project that it goes from Sea Grant to the Department of Urban and Regional Planning in the County of Kauai. With that, I will move into this. So community vulnerability assessment, it's kind of a long word, but basically it is community members, they gather and they're discussing a specific hazard or specific constraints for a specific area. So for this project, it's discussing sea level rise and the vulnerability that the areas in West Kauai have. So with the project, this is broken down into 4 phases for the timeline. There was phase 1, which is the stakeholder assessment, in which me and 2 other people of the Sea Grant team went and interviewed 27 asset managers and community stakeholders and asked them what areas in the community are vulnerable to sea level rise, how would they like to adapt to sea level rise, and what specific hazards do they think are going to be the biggest stressors for West Kauai. And then with that, we have began to move into phase 2, community meetings, which is from the interviews, there were management concerns that were brought forth, and these are presented at the community meetings. And then from the meetings, we are distilling out adaptation options and public and private actions that the public can take and private homeowners can take to help the community adapt to sea level rise. And with this, those adaptation options will be put into a final adaptation report that will then be prepared and then presented out to public presentations such as this. So with that, here is the results of phase 1. As I mentioned, there was 6 management concerns that were taken from the 27 interviews. So there was all of this information that was given to us. There was stories. There was what specific areas are best for fishing. Tales of how somebody could canoe from Hanapepe all the way up to PMRF before the sugarcane industry was introduced. But from all that, the main 6 themes were transportation, drainage and levees, critical infrastructure, coastal properties and beaches, cultural resources, and agriculture. So in each one of these community meetings that are discussed, and it's hard to see on this map, and I apologize for that, there are specific points that the community members mentioned in their interviews, and then they were plotted on this map. And then with with the information gathered from the interviews and going into the community meetings, we use a facilitation software called DCAPS, but it stands for Vulnerability and Consequences Adaptation Planning Scenarios. Sounds like a big deal. It's really not. It's just a fancy flow chart that plots a conversation in a very easy manner. So we start with the management concern, and let's say transportation. So we throw out transportation on there, and we have the facilitator talk about this, and then what hazard or climate stressor does the community think would impact transportation? So sea level rise. So they have sea level rise, and then what outcome would come from sea level rise with transportation? Oh, there would be flooding on the roadway. Okay, so then what consequences would happen from flooding? We'd lose access. So that's great. We have all that, but how can we translate that into an action that can be taken forward? So with this, in the community meetings, it's not just community members, it's also asset managers and stakeholders. So people that are there implementing the policies and formulating the policies. So we come up with public and private actions that will then be put into the final adaptation report and then brought forth into the West Kauai community plan that's being updated. Thank you.
We can hold our questions till the end. We can have our next Flo La Valle come up.
Aloha, I'm Flo La Valle, and I'm a PhD student in the Marine Biology graduate program, and I'm presenting today on our project in Hawaii's Intertidal, or OPIHI for short. Good. So before we begin, I just want to give you guys a difference between OPIHI with the Athena. So OPIHI with the Athena, yes.
What is intertidal?
I'll tell you in one slide. Next slide. So OPIHI with the Athena, as you all probably know, is the limpet that lives in the intertidal. And maybe some of you guys have eaten that before. While OPIHI in all capitals without the Athena is an acronym that stands for Our Project in Hawaii's Intertidal. And that's the program I'm going to be talking about today. So the intertidal, great question, is an ecological zone. And it's the area along the shoreline that is covered by water during high tide and that is exposed to the air at low tide. And the intertidal is culturally important here in Hawaii because it was where native Hawaiian women limu or algae and invertebrates for different food, medicinal, and spiritual practices. So for example, I'll give you an example, limu kala, which is this one. Limu kala is really delicious if you fry it up, so it can be food. If you get cut on the reef, you can chew it up, and it's really high in iodine, so it's an antiseptic. So you can put that limu kala on your wound, and it acts like a Band-Aid. And it's also used in Ho'oponopono, which is the forgiveness ceremony. Say I had a feud with Liz. If I wanted to ask for her forgiveness, I could give her limu kala as a token, and hopefully she would then forgive me. Because the intertidal is at the interface of land and ocean, it's really vulnerable to threats such as nutrient inputs from surface runoff, as well as groundwater. It's also vulnerable to species introductions. For example, when ships come in and they have ballast water that might have some species that are not native to Hawaii, that can be a problem. And because it's really easily accessible, the intertidal, there's a lot of over-harvesting of edible species, like OPIHI. The intertidal is also vulnerable to climate change as well as sea level rise. So the intertidal is culturally and ecologically important, but it's really understudied here in Hawaii and as well as other tropical systems. And that's because people usually come here to study coral reefs. They're very charismatic. I study coral reefs as well. But also our intertidal organisms are very small compared to other places. Like think of California has really giant kelp, really big limu. And here, in order to study limu, you have to get down on your knees and look really close to the ground because everything is super small. So it gets overlooked a lot. It's also a really tough system to study. So we have seasonal waves, and so we really can't study the intertidal in the winter. We only study it during the spring. And we also have a really small low tide window, meaning that at low tide, when the intertidal is exposed to the air, that's when we can study it. But it's only exposed for about 3 hours. And then at high tide, it looks like this. Zoom mouse. It looks like this. So this is Diamond Head at low tide and high tide. And so it's much harder to sample at high tide. So because the intertidal is really understudied, we created this Undergraduate Internship, OPIHI, where we do field-based ecological research. We've done this for 4 cohorts now, and we've had about 40 students total. The internship has both educational and scientific goals. The first one is to mentor the next generation of community ecology ambassadors throughout the entire scientific process by engaging them in authentic place-based research. And we say community ecology ambassadors because we recruit from a very diverse pool of students. So they're not just science students. So we don't expect them all to become researchers, but we do expect them to gain scientific skills and to gain an appreciation of their environment. We also want the students to use the data to create real scientific products. So our collaborators, and I'll talk about that a little bit later, they definitely use the data in order to create publications for journals and to present at conferences. But we also ask that our students present back to the community, create reports, do posters at conferences as well. And finally, we want to provide opportunities for the students to network with researchers and community groups engaged in the study and protection of coastal ecosystems. So the way that we try to hit all of our goals is through this nested collaboration structure. So in the fall, I teach a semi-structured class. We meet every other week. And I teach the students a lot of content and give them background knowledge and train them in the field as well. The students spend a lot of time doing their small group projects. So in the fall, our collaborators come in and give presentations on their research and the framework of their research. And then the students kind of rank them according to their preferences. And then we put them in small groups of 4 to 5 students. And they do research projects within the framework of that scientist's work. And they do this throughout the entire year. In the fall, we also do a cohort project, which is really to build community. So we want them to really trust each other. It's great if you go out in the field with someone you trust. And also, it gives me a chance to check out their skill levels. So some students are better in the water, some students are better at data analysis. And so when I create the small groups, I want a diverse group of students, a diverse group of skills. And finally, we expect that the students present their work back to the community where they've been doing their work. And we do that by doing formal presentations as well as outreach events. So we've worked with Eva Boys and Girls Club, Malama Mauna Lua, Hanauma Bay this year, most likely. Yeah. Okay, so that being said, we are halfway through this year's cohort, right? So the students have written proposals about what they want to do, but they haven't collected any of the data yet. So I'm gonna tell you a little bit about each of the projects, but it's gonna be a very coarse overview of what the projects are because they haven't collected any data yet. So our first project is going to be a collaboration with OPIHI, and they are the caretakers and the owners of Heia Fish Pond, which is pictured here. We're also going to be working with Rosie Allegado, a researcher from UH. And OPIHI is really interested in looking at what the mullet are eating. So mullet are really important for Hawaiian fish ponds. It's usually the main fish that they cultivate. And the fish pond has two different types of mullet. They have the native striped mullet and the invasive Australian mullet. And right now, the invasives outnumber the natives about 10-1. So OPIHI really wants to know what the native mullet are eating so that they can cultivate whatever they're eating and make sure that those numbers go up. So this is Hi'ilei Cavello. She is trying to teach us how to throw net, and it was hard. It was great. The students will be collecting their own fish, and then they'll be dissecting them and looking at their gut content in order to figure out what they are eating. And so this is just an example of what the invasive and the native mullet look like when you open them up. Our second group project is a collaboration with Fish and Wildlife Services and the biologist Kaua Fraiola. We are doing this work at James Campbell National Wildlife Refuge, which is in Kahuku on the North Shore. And the refuge is really beautiful. It's really great. They have these wetlands that are man-made. They can control how much water goes in the wetland. And these are really refuges for shorebirds. We're going to be looking at ghost crabs and their densities across the shoreline because they're food for native shorebirds. So a big problem in the refuge is the yellow crazy ants. They're invasive, they're originally from South America, and they swarm both shorebirds and crabs and spray acid on them and kill them and eat them.
How long are the crazy ants?
How long?
Length.
I'll show you. How about that? So this is a bird that's been swarmed by yellow crazy ants. And, they blind the birds with their acid. They're pretty, they're great predators, I guess.
How long have they been here?
That's a great question. I don't know how long they've been here. I don't know. Sheldon she's the biologist who works on the ants for Fish and Wildlife. I'll ask her. So I know this is really tough to see. I'm sorry about that. Where's the mouse? Okay. So this is the shoreline of James Campbell. And you don't really have to read any of that, but these yellow patches are where the ants are on these sides. And so the students are going to be doing surveys along the entire shoreline and then seeing if there's a correlation between the density of the ants and the density of the crabs. So in South America, for example, the yellow crazy ants are responsible for the extinction of one of their crab species. So we're pretty worried about what they might do to our crabs. And our final group project is in our backyard, Honolua Bay. And it's a collaboration with Megan Donahue, who's a researcher out at HIMB. And a big question of Malama Manalua, the nonprofit that works out there, and all the stakeholders in the bay is how can we make our reefs healthy again? If you've been in the water, you know they're very full of macroalgae, not as much coral. And so the first step to figuring out if we can increase our coral numbers is to figure out if the little larvae are settling on the substrate. So this is a coral colony. They release eggs and sperm that combine to create a planula. And that planula then settles, has to find somewhere to settle. And then if it is not outcompeted by other species, it can grow into a big coral. So we're putting out terracotta tiles at different distances from shore to see if we can find any coral settlement on these tiles. So these tiles are great habitats for the coral to settle on. But we're already seeing some issues. For example, close to shore, there's a lot of sediment. And when there's a lot of sediment, it's really hard for coral to settle. In fact, it's hard for anything to settle except for maybe bacteria. And then further offshore, we do see a lot of settlement. We see some sediment, but we see mostly macroalgae. And that over here, the big stuff, is actually Acanthoptera spicifera, also known as spiny seaweed. And this is invasive. So hopefully by looking at what is settling, we can figure out whether the coral will be able to increase in the bay. So things to look forward to in the spring. The students will be collecting this awesome data. They'll be able to answer these questions. I am actually moving on. I just finished my PhD. I just submitted my dissertation yesterday. We just hired my replacement, Patrick Nichols, at the top left. So he'll be taking over this project from me, but I'm sure I'll still be involved. And I just wanted to take a minute to thank all of the people involved with OPIHI. There's so many more. I just wanted to shout out Joanna Filippov, who's the PI on this project. Anushka Fauci and Jessica Schaefer help with the other arm of OPIHI, which I didn't talk about today, but basically involves teachers and their students taking ecological data across the main Hawaiian islands. And of course, I want to thank all of our funding sources, but especially Sea Grant, because they funded this for the last 4 years, and they funded my entire dissertation. So thank you, Sea Grant. I have to thank all of our collaborators that are listed up there, and I want to thank also Liz and Cindy and Mahealani and Maya and Darren. So, yeah. Well, thank you.
Okay. You want to wait till later, or you got a quick question?
No, it's not a question, it's a statement.
Oh, yes.
Hawaiian words are very important.
Yes.
OPIHI, you
Yes.
need the diacritical marks.
Right,
You
right.
should have in front of the O and a line over the O. It's OPIHI, it's not OPIHI. OPIHI.
Right.
Yeah.
Oh, the kahako, is what she's
Oh, the
talking about.
kahako.
Yeah, she's talking about the kahako.
Sorry about
Hawaiian words.
Yes.
It's very important to have the diacritical marks.
Yes.
It's a living language.
Yes.
Sisi? Great.
Hello, everybody. My name is Sisi. Where's my slide? My topic. I'm a second year PhD student in economics. So my topic is how does economics activity affect water demand on Oahu? Why this topic is
Excuse me, you have
yeah.
to speak louder.
okay? Why this topic is important? Because global water supply is very limited. Especially, everybody knows that, especially in Hawaii, there's empirical evidence showing that the water supply is diminishing over time in Hawaii Islands. So now our following question is it water supply is enough, and how much water do we need in the future? So thinking about water demand, so what do we need water for? We use water every day. We use drink water, we use water to take a shower, flush the toilet, wash, do the laundry, wash the dishes. So this it's in our everyday life. And so it's like intuitively, if everybody using water every day, we have if our population is increasing, we project like a higher water demand in the future. So we have these correlations between population and water demand. So there's a research from BWS, which is the Board of Water Supply. They have done a research to based on population, they have a focus on water demand and the past water consumption. So their research says, you can see from this graph, the two blue lines, the demand projection. The darker blue one is the high range demand projection. So which is like in a severe situation, what is the highest the possibility for the demand. And the lighter blue one is the most probable demand projections, like based on like more realistically speaking. And all the dashed lines are the supply focus. So it's the supply focus in different scenarios. In the orange one, the lower one is available supply during drought conditions. So this is the lowest supply focus, they said water could be. And the green one is the available supply during the more normal conditions. So if we can look at this graph, even we compare the lowest water supply possible to the highest range demand projections, it seems the water supply will be enough for the future demand, at least till 2040. But is it really true? Besides population impact water demand, we have other economics activities that also impact water demand. So what are the other economics activities that impact the water demand? It's just similar to the population, that when we have a bigger population, we have a higher water demand. And then economics is the same. Economic activities is the same. When we have a higher economic size, we will have more water consumption. So here are a couple of examples. A couple of examples of economic activities that impact water demand. The first one is tourism. Like, as you all know, that Hawaii is in Oahu is tourism is one of the biggest industry here, and we use water for like swimming pools, showers, landscaping in the hotels, and all these like resorts. And then healthcare industry is also one of the biggest driver for water consumption. It's like they use it water in hospital, healthcare facilities. And the third one is like the restaurant. They use it to wash dishes, mainly, like you use a lot of water. And the last one is agriculture industry. They use water for irrigations, etc. So these are just examples for economics activities. And how does the question is, how are we going to measure these economics activities? So let's see example. Let's think about the example. How are we gonna measure these economics activities? So, for example, in a restaurant, if the water consumption goes up, what does it mean? It means there's more dishes to wash, probably, right? And if there's more dishes to wash, there are gonna be more customers come to visit. And if there's more customers come to visit the restaurant will have more profit. And if the restaurant have more profit, the restaurant will want to expand their business and to get more profit. So if the restaurant expand their business, they will need to hire more employees, hire more people. So the employment goes up and the unemployment rate goes down correspondingly. And the demand for labor goes up. So if demand for labor goes up, there's gonna be higher wages. So the wages will go up in the restaurant industry. And imagine if this applies for the whole economy, everybody has a higher income, you will be more likely to go out to eat more often, right? So if everybody going out to eat more often, and the restaurant customer number will increase. And then there's gonna be more water consumption in the restaurant. So that's like a circle. So according to this example, we have three measurements for the economics activities. We say employment, unemployment rate, and wages. So these three, what we call economics indicators. So we can use these three to measure economics activities. So the next, what we're gonna move on to, now we have the concept of economics indicator. And the next one, we're gonna see a little bit technical things, but I'm gonna keep it quick. So this is our economics indicators. We just said employment rate and wages, right? And in this one, we have visitor arrivals because as in Oahu, visitor tourism is, so we want to use number of visitors arrival daily as an indicator for tourism industry. So you can see this 4 indicators, they're more or less going in the same direction, which makes sense because the economics activities, they're more likely to be correlated and go in similar directions. And also from these 4 indicators, we want to have one single indicator, like one single index to represent, to summarize all the 4 indicators. We call it coincident index. So the next page is the coincident index. You can see it's more or less in the middle of all lines. They summarize all the directions with less fluctuations. It's clear, give more clear direction for where the economic activity goes. So with this economic, we call it CEI, coincident index. This is the one that we're gonna use to measure economics activities. And the link, let's see. So what is our topic now? After seeing all these technical indicators, we want to measure water demand, right? So work, remember, but the population work that has done, what is this agent called? The BWS, population as measurement for economic demand. Now we have our economics indicator, so we can quantify this, connect with water data to focus the future water demand. So that's so far. Yeah. Any questions?
Are the wages now adjusted for inflation?
The wage is adjusted. No, it's real wages. It's real wage. It's adjusted after inflation. Yeah. Yeah.
Could you go back to your first graph that shows the employment? The next one.
Okay.
I looked at the years 2000 to 2010, the employment increasing. My question first, if it is increasing, my question is the population increasing?
So the employment
I'm
is
thinking that about 10-year span, 2000 to 10. Do we know if the population is increasing?
the population is always increasing. Yeah.
Okay, go back to the blue, the graph before this one,
Before this one,
the projected,
this one.
yeah, we
Yeah.
stopped there.
Yeah.
Look at, I missed a year, but around 2010 to 220. I think the other graph showed an increase in employment, but notice that the water supply predicted is level, right? In 15 years. Is the population going up in those 2010 to 2025?
Yes, the population is going up. For this one, it's like a projection for water consumption. So this one is not. Yeah, this is water.
That's
So
my question.
yeah,
In this case,
Is
if
what?
the population is going up in
Yeah.
those years,
Yeah.
why is not the consumption going up?
That's a very good question, because that's the other part of the project. We will take into technology into consideration. So the water consumption might going down if we have a huge technology improvement. For example, we can like save water, like when you change like your shower, like less water go through the shower head, and you will have like you consume less water when you take a shower. So this kind of like or maybe other technology gains that you will have. So you will per person per capita you will consume less water.
Okay. My next question goes to the second speaker.
Okay, cool.
If I can
Yeah.
ask
I'll get
the
So what we'll do now is you guys can all come up and then I'll turn on the lights and we'll just do Q&A for everybody.
You see, you showed the terracotta tile,
Yeah.
and it had a red color, brown red color, and you placed it down, and I saw one, not the first one, the second one.
Yeah.
It turned just about paper white. Is there a reason why that?
Yeah, it's sediment, actually, and it's calcifying algae.
The picture before that one wasn't white, it had a green.
That was after 6 months it's been out there.
Okay, so that's it. And I have one more question, if I may. The one that spoke about the mullet. Do you know when the invasive mullet came here and how it got here?
That's a great question. I don't know when all of these invasives came in. I'm a legal person. My personal research is in algae, so I don't know when the.
Was it introduced?
Yeah, most likely.
Thank you.
Yeah, no problem.
I asked two then. What are the units for water there?
Oh, it's a gallon per day.
Is it a million?
Million gallon per day. Yeah, I'm GB. Million gallon.
Thank you. And regarding the coral settling plates,
Yes.
use terracotta.
Mhm.
I think I've heard, but maybe it was not for coral, that coral prefer to settle where they can tell there's been coral before.
Mhm.
And yet you're using terracotta.
Mhm.
So how does this affect the validity of your results?
Absolutely. So having any bare substrate out better than what's already out there, because there's a lot of humus out there, algae. But yes, there's many cues that for settlement, and one of them, is where there were other coral, and one of them is if there's CCA. So we actually expect other things to settle first before coral can actually settle. So some of the plates have some CCA, crustose coral and algae, which is probably the white stuff you were seeing.
Sure.
Yeah. So it's a great question. I mean, it's not perfect.
So how long do you
Yeah.
have to wait before the coral might recognize that there's someone other than Terry interested in?
Great question. So most corals spawn in the summer. So we actually put these out in the summer. And there might be corals fat, they're called, out there, but we have to bleach the tiles in order for us to see them. So hopefully, we're actually taking them out in January, so hopefully we'll see some of them. Mhm.
Water economics.
Yep.
All of your projections suggest that larger population, greater usage.
Yep.
But you're not injecting any cost factor. What if the cost of water were to double or triple? What is your projection? And what about the new technologies?
Yeah, that's what I just
coming
like
in?
his
Another
question. Yeah,
question.
yeah.
But we could use a lot less water.
Yeah.
Even with an increased population.
Yeah. That's their analysis from BWS or something like that. BWS, yeah. So their projection, they have different scenarios, and I use this as example, saying that population is not the only driver for water demand forecast. We will have a lot of other economics activities in the following slides, and also we'll take into consideration the efficiency gains from technology improvement. Yeah, so this is just a start from this project. Yeah, very good question.
Well, certainly, if you were to double the cost of water, you would introduce a lot of conservation.
I'm sure about it, and nobody thinks shower anymore.
Maybe I'm interpreting this wrong, but the available supply line meets the high range demand in about 2040. Are we not looking beyond that at this point?
Yeah, this is just, I use as an example from their research. So they just have a projection till 2040. So I mean, we can have a longer, it depends on, how long is the timeline you want to see.